Hey guys, in this video we are going to be talking about the basic operation of CTs, commonly known as current transducers or current switches. These devices are very useful in motor control. They have the capability of not only telling you a status of the motor by reading the current, they also have the ability to actually start or stop a motor. This type of CT is current sensing only. That means all it does is report a status if it sees current flow. We can see here that the main power line for this motor starter is run through the CT. This is the incoming power to this starter. On the other side is of course the outgoing to the motor. In this type of configuration, you can mount the CT on either side of the starter as long as there is nothing else that is pulling current from this source. Say if you have a control transformer that is being fed from the primary side, you do not need to put the CT on the primary side. You will need to put it onto the secondary side. You can see here we have the connection for the status wires. Once the CT sees current flow, it will close those contacts that are on the CT itself. It will close those contacts, and that wire there actually goes back to the system controller for this particular system. Once it sees current, it closes those contacts, and once the contacts are closed, the system sees there is a current flow through this, and the pump, in which case that it is running, it will show that the pump status will be on. When there is no current flow in the system like there is now because the power is off, but when there is no current flow, the contacts will open, and then it will show that there is that the system status is off for this pump. Now this type of system has an additional relay that is enabling the motor starter. There are versions of these CTs available that have built-in relays where it's all contained within one device. You will have a control wire coming from your controller that is connected directly to the CT. There's also a set of contacts for the status, as well as another set of contacts that would actually enable the motor starter. Here we have this motor starter controlled by an additional relay. You can see the connections here that there's connections from the controller, and the controller will fire this relay. Then this relay will start the motor starter itself, will pull the starter in. We'll then see flow of current through the CT. The status will go on for this pump on the system because those contacts will close. This type here will not only determine status if it sees current flow, but acts as the control relay. The connection here for this particular CT is the input from, the output from a controller. Once the controller tells the motor to start or whatever it's connected to, once it turns on that output, the CT will then close the contacts here. Once current is then determined when those contacts close and start the motor, the CT will close these here, indicating that there is current flow. You can see here that the output on this particular CT goes down to our motor starter. Once again, the CT, it sees an output from the controller, it closes its relay contacts, and then once current is proven, the input is then sent back to the controller. What I'm going to do now is I am going to command the system on so you can see how the relay reacts. can see, when I turned the command on, the relay enabled, it closed its contacts, started the motor, and we also have a status on the exhaust fan as well, and that is because it is seeing the current being pulled through the through that phase. Now I'm going to release the override on the controller, which will open the contacts for the starter, dropping the starter out, which will then also turn off the status since it will no longer be drawing current. When selecting the CT for your particular application, you need to remember that you do not need to select one that is too large. If you have a CT that has a range higher than the rated load of your motor, you could get some untrue statuses. You know, your motor may actually be running when you show a status of off. So you want to make sure that you keep the range within the actual load. A little trick that can help is taking the lead that you run through the CT to measure the current and actually wrapping that around that CT a time or two. If you have a CT that's just slightly larger, or if it's just on the very edge of the range for the motor you're using. Anyways, guys, I hope that this has helped you get a little bit better understanding of the operation of the CTs. Once again, there's several different manufacturers out there for these devices. Honeywell, I think, makes some. Johnson Controls makes some. Hawkeye. I mean, there's little differences in styles. You can also get the type that are split to where you do not actually have to unhook your wires to install it. You can actually just clip it around the motor lead. But anyways, guys, I hope this helps you, understand how they work a little bit better. If you have any questions, leave them in the comment section below. Also, I'd appreciate it if you give this video a thumbs up, and be sure to subscribe if you haven't already. And once again, thanks for watching.